Ladies and gentlemen, welcome back to Drive&rpm. Today, we are not here to talk about a car. We are here to talk about a funeral. The funeral of Western aerodynamic dominance. For decades, we have been told by the engineers in Stuttgart and Detroit that physics has a limit. They told us that a production saloon car simply cannot slice through the air with a drag coefficient lower than 0.22 without looking like a science experiment or costing £250,000. They pointed to the Porsche Taycan, the Mercedes EQX, and said, "This is the peak. This is as good as it gets." Well, I am holding the spec sheet for the Dongfeng EP007, and it seems nobody sent that memo to China. Because this machine, this absolute weapon of efficiency, has just clocked a drag coefficient of 0.219 CD. Let's pause. Do you understand the magnitude of that number? 0.219 is not just good. It is effectively a glitch in the matrix. It is hydrophobic to air. In the world of fluid dynamics, drag is the enemy of range, the enemy of silence, and the enemy of speed. The Dongfeng EP007 doesn't fight the air. It negotiates a surrender. Look at the front fascia. In the West, manufacturers are still obsessed with fake grills to simulate a combustion heritage that no longer exists. Here, it is surgical. The nose is completely sealed. But look closer. Hidden within that lower intake are active grille shutters. These are not just plastic flaps. They are intelligent aerodynamic aids. They remain clamped shut to force the air over the bonnet, reducing turbulence to zero. They only open, and I mean only, when the thermal management system detects that the battery or the Mach-E powertrain needs critical cooling. The rest of the time, they are a solid wall against drag. Move to the side profile. This is the water drop philosophy in metal. The door handles, flush. The windows, frameless, sealing perfectly against the rubber to prevent that annoying wind whistle you get in a Tesla. And the wheels. Oh, the wheels. These are not just alloys. They are aerodynamic covers designed to suck turbulent air out of the wheel arches and smooth it down the flank of the car. This utilizes the Coanda effect, keeping the airflow attached to the bodywork for longer, reducing the low-pressure wake at the rear. Why does this matter? Because physics broke. When you reduce drag from 0.23 to 0.209, you are essentially giving the car free horsepower. You are deleting the resistance that drains your battery on the motorway. While a BMW i4 is fighting the atmosphere to maintain 70 miles per hour, the EP007 is gliding. It requires less energy to move, which means less heat in the battery, which means longer life and faster charging. This is what happens when you design a car in a wind tunnel, not a boardroom. Dongfeng has proven that you don't need a legacy badge to master the air. You just need better math. Now, let's strip the skin off this beast. Let's get to the bones. Let's get to what we call on this channel, the yellow chassis. You are looking at the Dongfeng Quantum Architecture Note 3, and before you dismiss this as just another EV skateboard, let me stop you. This is arguably the most advanced mass production electric platform currently coming out of China, and that is saying something. The headline here is CTB, Cell-to-Body Technology. In the old world, the world of the Volkswagen ID series or the Ford Mustang Mach-E, the battery is a separate luggage item. It's a heavy box bolted underneath the floor. It's dead weight. In the quantum architecture, the battery is the floor. The top cover of the battery pack serves as the floor of the cabin. The cells are integrated directly into the chassis frame. What does this do? Two things. First, it creates a torsional rigidity figure of over 40,000 Newton meters per degree. To put that into perspective, that is stiffer than a Koenigsegg carbon tub from a few years ago. It is stiffer than a Land Rover Defender. The car is a solid block of granite. This means no rattles, no squeaks, and absolute precision when you turn the wheel. Second, it lowers the Z-axis center of gravity. By deleting the extra floor panels and integrating the heavy cells lower down, the EP007 has a center of gravity that rivals a dedicated sports car. And then there is the suspension. We are looking at a 5-link independent rear suspension. Why 5 links? Because it allows the engineers to separate the longitudinal forces from bumps and acceleration, from the lateral forces, from cornering. A cheaper 3-link or torsion beam setup forces you to compromise. With 5 links, you can have a ride that is soft over potholes but rock solid in a corner. It is the patch magic carpet effect, but with razor-sharp handling. Look at the subframes. They are designed to absorb energy, channel crash forces away from the cabin, and isolate the motor vibrations. And notice what is missing: the transmission tunnel, the prop shaft, the exhaust routing. This is pure, unadulterated electric packaging. It allows for a flat floor in the rear, massive legroom, and a front boot, frunk, because the motors are so compact. This chassis is why the Chinese are winning. They aren't adapting old petrol platforms like BMW is doing with the Clar architecture. They are starting from a blank sheet of paper, and the result is a platform that makes Western cars feel heavy, compromised, and ancient. Now let's talk about violence. Silent, electrical violence. Dongfeng calls this the Mach-E powertrain. Yes, Ford uses that name, but frankly, Dongfeng's engineering here is so superior that Ford should probably apologize and hand over the trademark. We are looking at a highly integrated drive unit. This is an 8-in-1 system. The motor, reducer, inverter, PDU, DC-DC converter, OBC, VCU, and BMC are all integrated into one compact box. Why does this matter? Weight, complexity, efficiency. By integrating everything, they save weight. They reduce the amount of copper wiring needed. They reduce the number of connectors that can fail. And the numbers? The top-spec dual-motor version puts out 400 kilowatts. That is 536 brake horsepower and 640 Newton-meters of torque. But horsepower is for selling cars. Torque is for moving them. And this torque is instant. The F007 launches from 0 to 100 kilometers per hour in 3.9 seconds. Let that sink in. 3.9 seconds. That is supercar territory. That is faster than a BMW M3 competition RWD. That is faster than a Porsche 911 Carrera. And this is a family saloon that costs a fraction of the price. But the real physics-broke moment is the cooling system. Most EVs use water jackets around the motor. It's fine for cruising. But when you drive hard, the heat builds up inside the stator windings, the copper heart of the motor. Water can't get in there. Dongfeng uses direct oil cooling technology. They spray oil directly onto the stator and rotor. Oil is non-conductive, so it can touch the live electrical parts. This pulls heat away from the source dramatically faster than water ever could. What does this mean for the driver? It means repeatable performance. You can launch this car at every traffic light. You can take it to a track day. You can drive it like you stole it on the Autobahn. The motors will not overheat. They will not thermal throttle and reduce power like a Tesla does after 2 minutes of hard driving. The EP007 stays fast all the time. And let's not forget efficiency. This drive unit boasts an efficiency rating of 92.7%. The internal combustion engine, after 140 years of development, struggles to hit 40%. The EP007 turns almost every electron in its battery into forward motion. It is a masterpiece of energy management. This is not just an engine. It is a power station. And it makes the combustion engine look like a steam train. Step inside, and the humiliation of the traditional auto industry continues. If the outside is aerodynamic warfare, the inside is digital supremacy. The first thing that grabs your attention is the flipping instrument cluster. Visual. Show the screen flipping mechanism in slow motion. We have seen this on the McLaren 720S, a car that costs £250,000. Dongfeng has put it in a mass-market saloon. Press the S+ button on the steering wheel, or as I call it, the war mode button. The suspension stiffens, the throttle maps sharpen, and the instrument screen physically rotates, hiding the complex information and revealing a slim, focus display that shows only speed, gear, and G-force. Is it a gimmick? Maybe. Is it the coolest thing I've seen in a car this year? Absolutely. It adds drama, it adds theater. It reminds you that driving should be an event. Powering this entire experience is the Qualcomm Snapdragon 8155 chip. This is critical. In Western cars, the infotainment is often laggy, confusing, and slow. Here, it is smartphone fast. The 15.6-inch central screen responds instantly to touch. The graphics are 4K resolution. The menus are intuitive, but the real revolution is hidden in the code. This is the SOA, Service-Oriented Architecture. Most cars are hardware-defined. This car is software-defined. You can program the car, you can create scenes. Let's say you want to take a nap while charging. You press one button, nap mode. The driver's seat reclines fully flat. The windows dim electronically. The ambient lighting turns to a soft, warm glow. The AC adjusts to a gentle breeze. And the Wanos panoramic sound system, with 20 speakers, including in the headrest, plays the sound of rain falling on a forest roof. Yes, you heard me right. A 20-speaker sound system in a car of this price. The clarity is astonishing. The bass is tight. It puts the branded systems from Bose or Harman Kardon found in European cars to shame. And the materials? Organic silicone leather. It's soft, it's durable, and it's stain-resistant. You can draw on it with a pen and wipe it off. It feels premium. It feels expensive. There are no scratchy plastics here. The fit and finish are Audi level. This interior proves that China has moved past copying. They are now innovating. They are creating cabin experiences that make a Mercedes C-Class feel austere and outdated. The EP007 is a mobile lounge, a command center, and a gaming rig, all wrapped in leather. So, what is the conclusion? What have we learned today on Drive and RPM? We have learned that you don't need a 100-year history to build a world-beating car. We have learned that Mach-E 0.209 CD is the new benchmark for aerodynamics. We have learned that the yellow chassis with quantum architecture is superior to modified petrol platforms. We have learned that oil-cooled Mach-E motors provide supercar performance for the masses. The Dongfeng EP007 is not just a car, it is a mirror held up to the Western automotive industry, showing them exactly how far behind they have fallen. While European manufacturers are lobbying governments to delay emission targets because they can't compete, China is busy breaking the laws of physics. They are iterating faster, building better, and selling for less. This car offers the performance of a Porsche, the technology of a Tesla, and the price of a Toyota. It is a trifecta that should terrify every CEO in Detroit, Wolfsburg, and Tokyo. The Fischio broke, Nassim. The physics are broken. The game has changed. If you're looking for the future of the automobile, stop looking at Germany. Look east. I'm Drive and RPM. If you enjoyed this deep dive into the engineering that matters, smash that like button, subscribe for more content that the mainstream media is too afraid to make, and I will see you in the next one. Keep the voltage high and the drag coefficient low. Cheers!